Okay, so today we're going to talk more big circle problems, and these are not bad. We're coming to the end here, so let's work through this. So example number one says, given circle O with diameter BF. So I'm going to highlight diameter BF right away because we're going to see that's really important. I'm going to be moving the screen a lot around quite a bit, so you got to bear with it. So at BF is my diameter. I'm given that arc AB is 105, so I'm going to put the arcs in there right away. So AB is 105 or 105 degrees. I'm given that arc BC is 50 degrees. Fill that in. I have arc DE is 15 degrees. And then I have arc EF is 35 degrees. All right, so I think in order to find these different angles, which I'm going to be looking for, the strategy I'm going to take is to fill in the other missing arc measurements. So I have AB is 105 degrees, and then I have BF is my diameter. So what I need to do is I need to find AF, and I can do that because BAF is a semicircle, and we know a semicircle measures 180 degrees. So the first thing I'm going to write over here is 1 arc AF equals 105 plus X, okay, and that equals 180. So when I solve that, I know X equals 75. So I'm going to fill in for arc AF 75 degrees. Okay, now I need to find DC. So the second thing I'm going to do is find DC. And once again, I have BC at 50 degrees. I have ED at 15. I have FE at 35. I know that arc FEDCB, okay, is a semicircle. So we know that measures 180 degrees. So I'm going to set up my equation that marks that arc, CD equals 35 plus 15 plus 50 plus X equals 180. And I know that X equals 80 degrees. So I'm going to put that in there. All right, now I can start the work because a lot of this information, again, is just concepts and ideas of circles that we've already discussed in class. So let's go for the measure of angle 1. The measure of angle 1 is A here is, it's an intercepted arc. Okay, so it intercepts, okay, arc DCB. So I know it's going to be half of that. So what I'm going to do for angle 1, I'm going to add 50. Sorry about that. 50 plus 80. And that's going to be divided by 2 because I need half of it. And it equals 65 degrees. So I think it's a help if you put the angle measurement in there. And I'm also going to put it down here. So I'm going to kind of be sliding back and forth, so just bear with it. Try not to get dizzy and sick and all that stuff. All right, now I'm going to go for angle 2. So angle 2 is outside of the circle, and that is here. So we know what we have to do for angle 2, and I'm just going to highlight it a little bit because else it's going to get really messy. All right, so I know that's going to be half of these two arcs, 75 plus 35, and then that's going to be minus 50 degrees, so that's going to be half of that. So I'm going to set that up. So 3, so angle 2, I should have put angle 1 up there, but that's all right, is 1/2 of 75 plus 35 minus 50. Okay, because that's the major minus the minor, and it's 1/2 of it. So it's 1/2 of 110 minus 50. And that happens to equal 60 degrees, these two, so it's going to be 30 degrees. So angle 2 is 30 degrees. All right, let's go for angle 3. Okay, angle 3 is really straightforward in that it is a central angle. All right, the central angle here cuts this arc. All right, so we know that it is equivalent, and I should have put, for angle 2, I'm going to put 30 degrees. For angle 3, it's a central angle, so it's 50 degrees. So that's 50 degrees. All right, now, just just for curiosity, if this is 50, this is a straight line, so that's going to be 130 degrees. All right, but let's see if that comes into play or if we need that. All right, let's go for angle 4. So angle 4 is going to be this angle here. We know that it is the average of the two arcs. All right, so these two are congruent, they're vertical angles, so it's the average of the two intercepted arcs. Okay, so we know that one side is 75 degrees, so let's go angle 3 we did already, so we need angle 4. Angle 4 equals 75, and then that's going to be plus, well, let's see, we have this, and then we have the other side. So we need to add those up. All right, the 80 and the 50, and we're going to get 130, so that's plus 130. And that's divided by 2 because it's the average. And that's going to be 102.5 equals 102.5. And so does the other side. So I know my angle 4 is 102.5. Sounds like a radio station. Okay, and then angle 5. Well, angle 5 is a supplement to 4 because I have my straight line here. Let's do a little highlighting. I have the straight line, so it's a supplement. So if this is 102, then angle 5 is a sup to angle 4. So if that's 102.5, then angle 5 is 77.5. So put that down here, 77.5. All right, let's go for angle 6. And angle 6 has a different scenario for it. Before I do angle 6, I want to do angle 7. So let me do angle 7. Angle 7 here, all right, it's that same average again, all right, of the two sides that are intersected arcs. This is not cooperating at all. Okay, so angle 7 here, it's back up, is going to be that average again. So I have this arc here, so 7 that it cuts, and then on the other side, okay, I have that arc. So I'm going to find the average of those two. So angle 7 equals 80 on the one side plus 110 when I add those two together, and that's divided by 2, and that's going to equal 95 degrees. So I'm going to go down. I'm going to put 95 for angle 7. And then once I find angle 7, my strategy here was this is 95. Well, then this gets easier because I know that these two lines here are linear pairs. So I know they're supplements to each other. So angle 6 equals 180 minus 95. And that equals 85. So that's 85 degrees. And then I'll come down here. 86 is 85 degrees. Okay, let's go for angle 8. All right, angle 8 is inscribed in circle. All right, so that is here. Let's get a different color. And it matches the other one. How did I do that? Cool. All right, so it's inscribed in the circle, so we know it's half of the intercepted arc. So angle 8 is going to be half of 75. Pretty straightforward. So angle 8 is 1/2 of 75, which is 37.5. Okay, now angle 9. Angle 9 is going to be 1/2 of its intercepted, because it again in the circle, and I just stretch out. I have to add them. So I'm going to get 1/2. Angle 9 is 1/2 of 75 plus 105 plus 50. And if I put all that in my calculator, I should get that it is 115. 115 degrees. And then the last one, angle 10. Where are you? All right, angle 10. A little tricky, but no, it isn't. It isn't, because we're going to look at this. Let's highlight this where angle 10 is. Now, we have angle 10, and it comes down, and oh, my colors are going to match again. This is so cool. All right, so it comes down, and it intercepts here, but on the other side, it doesn't. So it's not an inscribed angle, but if I continue, all right, what do I have? I have a quadrilateral, all right, and I do have different degrees in the quadrilateral that I can use to find out what it is. That's one way, but I'm going to shorten the quadrilateral. There are a couple different ways of finding this. I'm going to shorten it up even more. So I'm going to use the green, and I'm going to use that quad. All right, because I'm looking for angle 10, and as I mentioned before, I know if this is 50 degrees, I know the other side is 130 because it's a linear pair. So now I have angle 10. That's going to equal, well, x is for angle 10 plus 130 plus 102.5 radio station plus 85 and all of that equals 360. So I know the sum of the angles in a quad equal 360. When I solve for that, I'm going to get x equals 42.5. All right, cool. So this was a little messy. That's because of all the different measurements that we have to find and all the different highlighting. What I want you to do is take your time with this video, and then go back and make sure that you're using your highlighter when you're doing your check your understanding and you're finding the different measurements for that circle. And also write down some key ideas. Go Cats, go Knights.